Let's consider the first question under chemistry. Which of the following organic compound is very soluble in water? Option A, ethanoic acid. Option B, ethyne. Option C, ethene. And option D, ethyl ethanoate. In organic chemistry, the solubility of organic compound in water depends mainly on these three things. The first is their polarity, second is the ability to form a hydrogen bond with water, and the third option is the functional group, the presence of a functional group. So let us examine each of the respective options, starting from option D. Option D, we have ethyl ethanoate. They are non-polar and insoluble in water. So that is not the right option. Option C, we have the ethene. This is from the alkene family or the olefins family. So they are non-polar hydrocarbon and also insoluble in water. Option B, we have the ethyne from the alkyne family or the acetylenes. They are non-polar and also insoluble in water. So the correct option on the board is option A, ethanoic acid from the carboxylic group. Next question, which of the following is used to hasten the ripening of fruits? Option A, ethene. Option B, ethanol. Option C, ethyne. And option D, ethane. Now, fruit ripening is controlled by a natural plant hormone known as the it is also called the ethylene from the alkene family or the olefins family. Ethylene is a gaseous plant hormone. It stimulates ripening by changing the color, increasing sweetness, and softening the fruit. So the correct option on the board is option A. Ethylene is the correct option. Option A. It helps to hasten the ripening of fruit. Let's look at the next question. Question number 3. The question on the board says, benzene reacts with hydrogen in the presence of nickel catalyst at 180 degrees Celsius to give option A, xylene, option B, toluene, option C, cyclopentane, and option D, cyclohexane. Now the reaction on the board is called a hydrogenation reaction. What is a hydrogenation reaction? This is a reaction where a hydrogen is added to a compound. But in this reaction, benzene is the major compound. And benzene is an aromatic hydrocarbon. It is unsaturated. What are the characteristics of aromatic hydrocarbons? One of the characteristics is that the molecules must be cyclic or in its ring form. Again, the molecules must contain an alternating pi bond around the ring. The pi electrons must correspond to the Hubble number for the aromaticity, which is the 4n plus 2 pi electrons. Again, the molecules must be able to undergo a phenomenon of ring resonance. Resonance in organic chemistry is the delocalization of pi electrons within a molecule. Again, these electrons, this aromatic hydrocarbon, they undergoes a phenomenon of ring resonance. They also undergo an electrophilic substitution reaction. So, the reaction between benzene and a hydrogen in the presence of catalyst gives, this is benzene molecule. So you have double bond, the pi electrons, the pi electrons, the pi electrons. This is a benzene ring. So when this ring, which is C6H6, reacts with 3 molecules of hydrogen gas, it will yield C6H12. So the correct option is hexane, cyclohexane. And the correct option is option D. It's going to give a cyclohexane. One of the major uses of alkane is that option A, as domestic and industrial fuel, B, in the hydrogenation of oils, C, in the textile industries, and D, in the production of plastics. Now, alkane are saturated hydrocarbons with the general formula CN H2N plus 2. They are also known as the paraffins. So the major use is fuel from cooking gas, example diesel and petrol. So the correct option is option A as domestic and industrial fuel. The question on the board says the final products of the reaction between methane and chlorine in the presence of ultraviolet light are hydrogen chloride and dash. Option A we have trichloromethane, option B dichloromethane, option C tetrachloromethane, and option D chloromethane. When methane reacts with chlorine in the presence of ultraviolet light, a free radical substitution occurs, and at first only one hydrogen is replaced. We have methane CH4 reacting with chlorine Cl2, chlorine gas, to yield a hydrogen chloride gas. At first, one hydrogen is replaced. One hydrogen from H4 is reacting with one chlorine molecule. One chlorine molecule. So at this point, we are left with 3 hydrogen here and one chlorine, one atom of chlorine at this point. So the next reaction is going to be CH3, CH3, Cl, 1Cl. So the reaction on the board is chloromethane. Chloromethane. And the right option on the board is option D. Chloromethane and a hydrogen chloride gas is going to be formed. But if the reaction proceeds, we are going to obtain a dichloromethane and so on. So take note of this. The first product formed is chloromethane. And the question says, 2 hydrocarbons, X and Y, were treated with bromine water. X dechlorized the solution and Y did not. Which class of compound does Y belong? Okay, option A, we have the benzene. Option B, alkynes. Option D, alkenes. Option D, alkane. Bromine water is used to test for unsaturation. So if a compound dechlorizes bromine water, it means that the compound is unsaturated. But if a compound does not dechlorize bromine water, that is to say, that compound is saturated. So on the board, alkane or the paraffins, alkane, they are saturated. While the alkanes, these are unsaturated hydrocarbons, unsaturated. Alkynes, they are also unsaturated. Benzene, because of their alternative pi bonds, they are in their ring form, so they are also unsaturated. So the only saturated compound on the board is alkanes. The question says X dechlorize the solution and Y did not dechlorize the solution. So the correct option is option D. Alkane family are saturated hydrocarbon, and saturated hydrocarbon does not dechlorize bromine water. So the correct option is option D. Alkanes. Question on the board. In the reaction above, CH3COO minus aqueous state is option A, conjugate base, option B, acid, option C, base, and option D, conjugate acid. So in the reaction above, ethanoic acid CH3COOH donates a proton. What happened after proton transfer? After proton transfer, ethanoic acid CH3COOH becomes CH3COO minus. Now when an acid loses a hydrogen ion, it is always a conjugate base that is formed. So ethanoic acid losing a hydrogen ion or a proton to form CH3COO- is called conjugate base. Take note of the concept. The product formed is called conjugate base. So the correct option is option A. The question on the board says, organic compound has an empirical formula CH2O and vapor density of 45. What is the molecular formula given that the atomic mass of carbon is 12.0, that of hydrogen is 1.0, and that of oxygen is 16.0. So the options are given below. So the first thing we must do is to determine the molar mass from the vapor density, and then also determine the molar mass from empirical formula given on the board. Okay, so the relationship between the molar mass and a vapor density is given as is equal to 2 times vapor density. 2 times vapor density. So the molar mass is equal to 2 times the vapor density on the board is 45. 45. So you are going to get 90. That is the first thing you must obtain. Now the next thing is to determine the molar mass from the empirical formula given on the board. So the formula is CH2O. CH2O. Now to get the molar mass, we are going to add each of the respective masses of these elements given in the compound. So we have C plus H2 plus O. So the next is to substitute their masses. The masses was given in parentheses. So C is 12. 12 plus H is 1. 1 times 2, subscript 2, plus O is 16. So we have 12 plus 2 plus 16, which equal to 30. Next thing we must obtain is to determine the multiplier. Let's call the multiplier small letter n. So multiplier is equal to the mass, the molar mass from the vapor density divided by the molar mass from the empirical formula. That is how to determine the value of n. So this equals to molar mass from vapor density, which is 90, divided by the molar mass from the empirical formula in the question, which is 30, and we are going to obtain 3. So how do we get the correct formula? Since this is the empirical formula given on the board, we are going to use this 3 to multiply the compound, and that is in parentheses CH2O was the compound given. CH2O times or subscript n. Subscript n. So this is basically the same as CH2O times 3. Remember, n is equal to 3. So let's do the calculation over here. If we multiply this by this, we are going to have C3. If we multiply 3 by 2, we are going to obtain 2 times 3 gives 6, and 3 times 1 gives 3. So the formula on the board, the molecular formula is C3H6O3, and the correct option is option C.